is that, where is this guy? Yeah, okay. Topic of today's webinar is the detection of camouflaged manual mapping bypasses, although they're just applications, they're just files, to say the least. So, I have several, well, not several, but I have an example. I have a sample of the bypasses, and I'm going to explain how exactly you detect those types of bypasses. So, it's going to be essentially pretty hard for all of you if you don't. Have any of you? I am talking. Okay, I'm deafened. Nice, nice. Have any of you read the screenshot guide at some point? At some point, at least some part of it. Maybe you have, maybe you haven't. 15%. Lots of guides. The merged guide, not all of them. The merged guide. The 515 pages one. Oh, okay. You have read some of it. Here's my question. Why haven't you guys, wait. Wait. Something weird going on. Okay. So why haven't you guys read the totality of it? Like actually all of them? Maybe at least like half of them. You know what I mean? And that's okay. That's okay. It's none of my business to judge. But on the rate 100% of him. For the rest who have not read the vast majority of the guide, it is going to be very complicated for all of you. This is a sample that I managed to detect. The file is not an executable. The file is also not a DLL file. Well, it is the header of the file is a DLL because it is a dynamic link library on Windows. But it is not essentially just a DLL file. As you can see, this has different weird sectors. So we're going to talk about all of this. Do you hear something? I don't hear nothing. Yes. Okay. Then I guess I will join or rejoin so that, yeah. Can you still hear me? Or if you were not able to, can you hear me now? Okay. Okay. So the two, good job. So the two, before we explain how exactly you detect manual mapping and camouflage, first we have to understand what we're talking about. In the screenshot guide, you will see that you have read that there are sections, there are pages where I talk about camouflaged files. A camouflaged file is a file that acts like a legitimate file, or has a legitimate file icon, has legitimate file properties, but is not legitimate. So it is a cheat file. When you hear of camouflaged, first thing you would think of is Katana, anti-screenshot tool, if you are low enough in this community. However, there are files, there are bypasses in the community that do not rely on, yes, Katana, that was the name of the bypass. So in the community, there are a lot of hidden and more of. Do I fuck this webinar over? No. Okay. So, uh, no. Point is, I'm waiting for him to join so that I can kick him. But okay. So the point is that those camouflaged files represent that nowadays they have begun faking the files structure. They have begun faking the files. Oops. Files signatures as well as the properties. They have also synced the files icons and the actual IPs that it connects to in order to receive the information from. For example, there are some bypasses that have different maybe website and network connections that all lead to the same verified, legitimate website. Although faking all of these is not hard, they have just begun doing that. I'm not going to say that every screenshot, that every server that you screenshot, or every bypasser that you screenshot is going to be using this, because this is a highly privated and highly self-developed bypass. You won't really see many of those, you won't really see any of those, to be honest with you, in the screenshot. However, I figured that because I recently detected it, so it was a week ago. No, it wasn't a week ago, it was yesterday, like 2 days ago. I figured I would share the detections to you, so that way you guys maybe have an imagination about those types of bypasses. Before we begin, which one of you has received a Lotus Plus without purchasing it? Was it you? Or was it not? Do you know how to assess? Okay. I think it wasn't you, was it? No, right. Okay. Sorry about this time, we'll have to lose it. Wait. What? What do you mean wait? Why? Because it was a temporary role, essentially. Although you can leave, you can stay with the rest of it. Because Lost Plus is actually something that, you know. Okay. Hello, Mindfold. Okay. You know what's, no, it's not really a part of it. It's just, yeah. So the giveaway they won is just there to be. Anyway, so as we said, the camouflaged file is a file that is hiding, disguised as a legitimate file. However, it is obviously a cheat file. The only way you would be able to detect this is by actually knowing how applications function and how they work. I'm going to try my best to explain their logic. It is nearly impossible to properly explain how to detect those files. The thing is that this exact file, this exact cheat, this did not load. I screenshot a guy without services to find this file. They had DPS disabled, they had PCSS disabled. Well, they tried to enable some of them. They also had prefetch bypassed. So it essentially did not log in any of those processes because it is not an executable file. So that is where it also did not log in CSRSS, it did not log in search everything, it did not log in CTVMon, it also did not log in registry, stuff like that, okay. Let it log in registry as a Hive, but it cannot log in registry as a process. So in order to understand those types of files, the logic is that it is not an executable file, therefore the first thing you do is that you analyze files that are not executable. So to do that, you would obviously have to filter for search everything, for example. Let's take that as an example. And we'll have to specify a range of files between the files. I have mentioned this in the guide. There are channels that mention this. But just for the sake of it, I'm going to show you what I mean. So the first thing would be obviously to guess a file range. Keep in mind that this file, although it was 11 megabytes, there are camouflaged files that are lower than 100 kilobytes. So that becomes very hard to find, very, very hard to find. Because lower than 100 kilobyte means that you'll have to dig through thousands of files, especially if it is a DLL. Let me show you how many lower than 100 kilobyte files there are. Lower than 100 kilobytes. No, this is not, no. It wasn't that simple. It really was not that simple, because you don't know the file size. That's not how any of this works. So as you can see, there are files that are lower than 100 kilobytes. There's at least 600,000 of those types of files, and it is impossible. Even with file scanners, it becomes impossible to actually detect anything. In this case, the way you detect these types of files, it does not have. It has a spoofed extension, but it is not a DLL file, and it is not an executable file. The extension is not DLL, and it is also not an executable. Those types of files, obviously. The detection is mentioned in the screenshot guide, but the way you do this is that you exclude DLLs and DXC files. So you do 200 kilobytes up to 25 megabytes if you want to, and then you extension executable and extension DLL. So this has removed all the DLL and executable files. But as you can see here, there are still 71,000 files. Out of those 71,000 files, also keep in mind that these did not flag path parser. Path parser did not flag this, and no service had a trace of this. So it is a weird file. Probably they did something with the file. It was also located in an admin elevated directory, so you would not be able to access the file because it was in an admin directory, which means that if it is in an admin directory, then scanners will not have access to that directory. For example, in my case, Xtool had no access to this file, although it did pick it up, but that's not how I found it. I was going to talk about how exactly I found it, because there are methods, because I already explained it to you. You still scan the files, and then you rely on your own observation. There is nothing I can say that will help you detect this file without reading the guide and without observing everything that you see. So, all in all, now how did we determine that this file is a cheat file? Keep in mind that this file is not only a camouflaged file, it is also a manual mapping file. Manual mapping is a technique which means that the execution of the file is standard, the file executes, but the deployment and usage of the file is spoofed. API manual mapping shit. No. So what that means is that in order for the file to display, you would have to press a hotkey. You'd have to do something to make it display. So although you execute the file, it will run a legitimate file, but it will not display the GUI, which is something that I find that a lot of beginners struggle with. If you just execute the file and you say, for example, you just see this. What do? You just analyze it, you just use it, you click on this, and you just think that this is a legitimate file. However, there are... Why is it animated here? Just don't worry about that. Because, yeah, it's the box Jordan trace that I asked it to make. So let me show you exactly what I... Should I not? Probably should not, but I hope that... I'm hopeful that you guys don't... Okay. That you guys don't really misuse what I showed you. So essentially, in the end, before I found the file, so I just executed. Okay, nothing shows up. Just nothing shows up. Okay, it's using an emulator, and currently, no, you don't need full screen. Okay, it's like this. The file itself is already executed. This was, by the way, a very throughout assist that I have done. You will see that the file itself is injected, because I injected it. It is executed. You see that in the modules of the file, as well as in the memory of the file, as well as in the handles of the file. There are other connections like the network connection, these and the volumes, but I'm going to show you that. So the file is executed. The GUI is open, but because the user is being screen shared with AnyTask, and because the user is sharing their screen or using OBS, it will not display. It will not display that. It will display nothing. Okay. This is where experience overshadows any knowledge that you might have. You might be able to find some complicated bypasses, but if you have the lack of knowledge or lack of experience with those types of files, you will not be able to find them. So in the end, I just uploaded to Aristotle after confirming that there is something suspicious about the file. Obviously, that's where you use comprehension. That's where you analyze the file yourself. Now I'm going to show you exactly what tells me that this file is a cheat file. The very first thing that you pay attention to. Okay, the very first thing that you pay attention to is the file type. Okay, it shows you that it is a Windows 32 DLL file. However, the P header of the file is for 64 or x64 bytes or 86 bytes of Windows. This doesn't really have a significant meaning, but those do. This says that the file is executable. Don't listen to this first line, because if I rename this to DLL, it will say that the file is a DLL file. The reason this says that the file type is Windows 32, so then you have to pay attention to this. The file type is not an identifier of the actual file type. This is not a Windows 32 bits application. This is a Windows 64 bits application. That's where you go to the magic bytes. The magic byte is the byte of the header of the file. And it tells you that the file is a DLL file. Shows you that it is a DLL executable. The alert executable means that the file is essentially a dynamic library that you can run, and it is a console file. We're gonna get back to this console later. This also shows you the generic IDs of the triages of the file. This is a Windows icons library, which is a generic detection. And you also see the PEPs of the file. So all of this now tells me that there is something wrong with this file, because the file type does not match up with the rest of the ID, the magic, and magica of the file. Another thing that we see, as you can see here, is that the header of the file suggests that the file's target machine is 64 bits, but the file type says that it's a Windows 32 application. The reason this says that it is an executable, and it says that it's a Windows 32, is that when you rename a DLL file into an executable, you are unable to execute it, okay? So bringing the file into an exe, it will not be able to run it, therefore this does not really understand what file type it is. The next thing you do is the checklist, the sections. The weirdest sections are those. These three are obfuscated sections. You don't see these with legitimate applications. You don't see these with applications that are open source, for example. Text are data, p-data. P-data means that the file also has a PDB, so a P database. Let me tell you what the PDB file database is. The database. Okay. So this is a file format, essentially. Program database, okay. So the program has a database. This means that it is not an application, it is a program which also functions as a database. That means that it receives the contents from a different file. For example, to show you that, do I have detected easy or I don't? Just for the sake of this webinar, I'm gonna download this so that I show you what I mean. What the fuck? What else would be left in there are no logs in prefetch. Portable, okay, let's use portable. Prefetch was bypassed and services were also bypassed. There was only this one method that I used, which I won't show you guys, that was able to detect it. The reason I won't show you guys the detection exactly is because the bypasser asked me not to, because it was private, so it was a private chain. But I'm still showing you the general idea. Even if you guys knew the method, you would not be able to detect this because you don't know how to read this, so I'm telling you all of that. So these are suspicious, obviously. It's not supposed to be here, it is not supposed to be random. It has to be stuff like this. And it is a portable. Okay. So let's take a, okay. So let's take a journal trace.exe. Let's do journal trace for this matter. Let's down this. Go to advanced, go to strings, and do PDB. As you can see here, this file has a PDB, which is a program database. So yeah, so as you can see here, it is a database. So this file also had that. That means that it is most likely a compiled cheat that was made on the device. However, as you can see, a lot of other executable files have this. But yeah, so it is already something to be suspicious about. Most of the time, that database tells you exactly could an imperfect use executed TLS. No, 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 no. It's just not that simple, okay? However, if you scan the files, you might be able to find it. It's not that simple, but if you find the files, if you scan the files, there is. Even if you find this, you will not be able to understand what to do with it. Because from my experience, everybody who screen shares, they want an easy way of detecting the hardest bypasses there are. There is no easy way of detecting a bypass. Yeah, but if it is deleted, you'll find the deletion trace. So they don't do that. That's where USN Journal comes in. And we'll also probably talk about USN Journal later. Read the guide. Don't ask this question. Read the guide. The guide details exactly how to understand USN Journal. That is also one of the hardest things that screen sharers think is impossible to find or impossible to do. But also they think that it is very easy. It is easy, because all you have to do is prove execution, check if the file was deleted, check when it was deleted, if it was replaced. And then there are bypasses that also, they don't bypass journal. Yes. Thing is that there are bypasses that don't bypass journal. But if it was executed through CMD, so what? So what? That doesn't... What's the... So, what's that bypass? You don't have a trace for CMD logs, but that doesn't matter how it was executed. Forensics is about finding execution. When you execute a file through CMD, it leaves traces everywhere. That is the worst type of a bypass there is. It leaves traces in prefetch, it leaves traces in system informer. There's a lot of traces it leaves. Except for when it is a DLL file. That also leaves traces, but I think that we can continue with our lesson. So then you have the imports. The imports of the file are actually more important than you guys might think. This basically tells you what exactly the file does. So, first of all, when you see the D3D compiler and you see VC runtime, that means that this file has a UI. So it means that the file has a GUI, so user interface, and it can be clicked. So you can click modules in that user interface. So there is a create device and swap chain. So what exactly does this import mean? D3D11 is a graphics card. So it is I forgot the name of the graphic card, but let me tell you that D3D11X. What's the graphics card? I forgot what this is for. DirectX, okay, yeah. So it is a DirectX graphics card library. Right, so this means... No, it's not. Yeah, it's just a rendering shit. So, this means that the file has a graphics card. It renders a user interface. And that is another thing that you should be suspicious of, but this doesn't prove anything yet. However, this does, and this also does, and this also does, and this also does. And what was this one? The what was it? The user create remote thread logging system on service. No, it doesn't. You don't have to create remote thread log. Sysmon is not a service. You don't use. So what I'm saying is that you scan the files. That will help you. You know what makes me angry sometimes when people who buy the course and then ask questions to, you guys don't read the guides. This question is answered in the guide. This is also answered in the guide. Everything is, so far even, this is answered in the guide. Don't understand what else to do. There's nothing. Okay, there, let me show you that it is actually answered. Let's do the... Right, okay, there is an entire chapter. There are chapters dedicated to it. People don't like reading 500 pages guides, and then they like asking 500 page worth of guides. I don't like that. So, when I say read the guide, it will be there. I hope that you guys know how to control F in the guide so that you find what you need. So another detail about this file is that you have co-create instance. Co-create instance means that the file itself is executed, but it also creates another instance of the file. So this is also suspicious. So all of these here, for example, even this one, in 32 DLL, and what does this mean? Let me show you the function of this file. So this means that it's not here. Is it here? Right, so correct input context before attempting to access information in the context. So essentially, this is a function that asks for the context, so the current input context. This means that you'll have to wait for the input chain. So that means that you will have to, for example, if the GUI displays on print, then they will have to press print in order for the GUI to show up. So these are suspicious, so this tells you that the file is not an executable and is not for Windows 32. Then go to relations. Relations is going to show you the domains of the file. For example, the signature of the file. By the way, these were faked. These are not the correct signatures. But essentially we'll see that here if the domains look suspicious. In this case, there's nothing much. The most important part here, by the way, is that you can also explore the thread in a graph view, or you can also check the headers, so the tags of the file. These tags will show you the most important details that you need. This shows you the file is 64 bits. It shows you that the file detects when it is being debugged. Debug monitoring is something that a lot of files have, but not a lot of legitimate files do have it. So it is essentially either a file that is obfuscated, as you can see here, this also shows you that the file is obfuscated, or a file that is commercialized. Commercial files are fine to have those two things, but other files that have no signature, it is suspicious. So that's how you comprehend that you have to check this. So here you have the activity summary. So you have the help box, you have the artifacts download. If you want to download artifacts, you can. And you have the full reports. Full reports of a file will show you other virus analysis. So here we have this, and here we have this. We'll get to those later, because now we have to check all of the details. First of all, as we said, the DNS resolutions are here, and it shows you the resolved IP addresses. The IP addresses of the application. So where exactly does the application gather its data from? Sometimes, if they host the bypasses in their own network, that IP or the network HTTPS will be here. That is usually something that you would want to still check, because this has nothing to do with the user's IP. This is not the IP of the user. It is the IP of the compiler that they use to compile or databases or online networks that they use to compile the file. So then we have the MITRE attacks. Hello, unfortunately, thanks for running this session. Okay, you're welcome. The recording will be sent after this, so, well, whoever sends me the recording. So then we check the persistence. Persistence is something that most of the files are gonna have. It allows side loading, so you can hover over the tags to see exactly what it means. The thing here is that hijack execution flow is the most unusual tag to have. So if you can just understand what this means, for example, if I hover over this and read that the adversaries may execute their own malicious payloads by hijacking the way operating systems run programs. So, what does this mean? Exactly. So you can right click on this, go to this, and you can also just click on this instead. This is a very nice website. This also shows you examples of malware that they had. And you can also read a lot of things here. For example, here you'll understand that. So you'll understand how most of the bypasses have the potential of working. Exchange files with additional code. Exactly. That also works. So here, this is a very nice website, by the way. I have learned most of my malware analysis from here, as well as some forensic courses, but this is very nice. So this event tells you exactly how a file will work, and this also shows you the command. So the definitions of the commands, and they show you the commands that they might have used. Right, so it's here. You can even download the website, blah blah blah. See, as you see here, this also shows you partial logging to disable. So this means that the partial detections are useless when they disable script logging. But this also shows you that this, oh my god, what the fuck. This also shows you that, okay. So this also shows you that this registry hive is responsible for it. So as you can see, this is a very nice website. I'm hoping that someday you guys will learn this. I was hoping that someday you guys would understand that the files and stuff that I dropped. This is, by the way, mentioned in the guide, the screenshot guide, but I guess none of you give a fuck about that. Something gives me a feeling that after we finish this, you guys would still ask me questions about this webinar, and that's where I'm gonna get pissed off. Anyway, then we have the privilege escalation. So it's the same thing over here, but there is a slight difference. It is about the is there a difference? Yeah, it is. Well, it is essentially. Difference is that the tag of this privilege escalation is different, obviously, but they have the same, exact same DLL matches. Is it completely the same, or okay? Essentially, that's it. Then we have the defensive evasion, and the defensive evasion. By the way, sometimes this will show you things like doppelganging. If you see that a file says doppelganging, you can just ban for it. There's nothing else you have to do. It will also say process hollowing. You can just ban for that as well. Those are the things that you can just ban for. Period. So then we have the defense evasion. This is probably the hardest thing that most screenshoters struggle with. Obfuscation. Obfuscation files. So obfuscating files for information. This explains what exactly obfuscation means, but we also have that described in the screenshot guide. So it is obfuscated, but then what you have to do after reading this is figure out how exactly is the file obfuscated. To understand if the obfuscation was done through. Oh, by the way, this also gives you the command. See? By the way, the thing that you see after this, so let me copy this. Can I copy this? Yeah. So the thing that you see after this, so this #1, that is where the script is actually being loaded. So that is a placeholder. Another thing here is that, well, obviously this shows you the command itself, but there is not much you can do about this. Because as you can see, run_dll runs run_dll, which runs the DLL file, which has a function. The #1 is the first function. You can also do that. You can also do like that. So we have talked about this with the fileless bypasses. So essentially this file is also a mix of a fileless bypass, because obviously it doesn't really inject a DLL file, but it injects a DLL function, which is malicious. So this, as you can see, this was a very tough file to really understand. So this is already something that also could have a placeholder like number 1, so it's only suspicious, exactly. So this is suspicious, so that's what I was about to say. This is suspicious, but this doesn't prove anything. Even now, it doesn't prove anything. This is indirect evidence. All of the rest that we just talked about, all of this is indirect evidence, because obfuscation is normal on every file. It's very normal. Even hijacking execution flow is normal. Discovery, however, is where things get interesting. Discovery shows you okay, this is not supposed to be here, but essentially it shows you that the file checks for the system information. Okay. Only, this is also suspicious, only suspicious, but only cheat files have something that cheat file. Just whenever I'm first, I was planning it. Actually, I did teach, but it is also written in the guide. So you will not be able to detect this file, even if I tell you how to detect the file. What you have to do is learn yourself. Learn, sit down, maybe read, maybe drink coffee when you learn, maybe drink something when you read. You still have to have some experience. I scanned this file, but it didn't tell me if this file was suspicious. I just decided that it looked suspicious. The reason it looked suspicious was that the file had a valid, verified signature, but the properties of the file did not really make sense. That's just my logic, that I can't really explain how that works. But the file itself had properties that were suspicious. That's the only reason I managed to find this. So it did not make sense. For example, let me show you what I mean by suspicious. So let's show what this file had. Let me tell you. Let's take something mkh Hive, right? So the property of the file was suspicious. What I mean by that. So as you can see here with the digital signatures and security and details. So in the details, so the date creation and date modification were suspicious, and the type of the file was also suspicious, because the file's name was mkh tool and show a signature. Yes. There are files, so I'm telling you something about a very hard bypass. This was not a bypass that you come across with every time. This is also not a bypass that anybody would detect 100% of the time, because, as I said, it's not it did not show the UI of the cheat. Even if I pressed the correct letter, I figured out that it was insert because not many keyboards have insert. That's why they use it. Also, another thing, whenever you see virtual keyboard, right, on-screen keyboard, make sure that you check everything that logged around this time. Do you know why they use this keyboard when you see these on people's devices? Can you guys guess why would anybody open this? Well, for cheating. Yes, well, yeah, I already answered it, but that's what the see, this guy's not listening. He's not listening to me at all. Okay. So the reason is that they don't have the insert, where's the insert button. So they have to press these for it to load up the cheat. That's why. So I have to check exactly what this guy is DMing me. Hello. Hello. What is it? Well, he wants me to screen share somebody. But anyway, let me finalize the ESS. Okay. So then we have the malware behavior and the catalog. So packing, okay, so packing is normal, and HTTPS communication is also normal. But another thing is that the command and control is what really gave it away. Because it shows us that it performs DNS lookups. Well, it's not really necessarily suspicious, but it is suspicious because that DNS lookup is not something that the name of the cheat should have had. Then just check for all the DLLs that were loaded into this. So there are things that don't make sense here. Things that are not supposed to be here. But I think I will explain these to send this to somebody else next time. So the first thing that does not make sense is why is Java here. Another thing is that what exactly is this file? Library DLL. So these two are one of the most strangest files that this has, but that's not necessary. Then we have the files written. This is actually very nice and very useful because this just gave me the name of the cheat and this just gave me the deployment of the cheat. So this file is a DLL file that has a UI, so user interface, but when I inject it, it doesn't show a user interface. What it does instead is that it makes the cursor lose access to the desktop. That is because the UI hovers and covers the desktop. I guessed that because when I injected it, so after all of this, I injected, the cheat opens, but I can't close the window. It doesn't get highlighted. So, but when I move my windows, yes, top window, it is always top window, not transparent, invisible. Transparent is at least visible at some point. It is invisible because I'm in Ndesk. He sees it, but I don't, because it only hooks into Ndesk. He can see it because that's his device, but I cannot. Snipping tool cannot be used because when you take a screenshot, it is a screenshot, so you can't see it at all. So this is what gave it away, mostly. But then you just have to analyze the registries that it opens. So the first thing that it opens, obviously except for those things, it's not really that necessary. You just pay attention to the names of the registries. For example, here, why does it access run-DLL registry? Simple, because it uses run-DLL. So then why does it access input registry? because, well, obviously it waits for a key to execute it. And then why does exactly it access the internet settings? Okay, so those are the things that you can't really answer. But then you have the processes created, then you have the process tree. All of this just gave me the method of the bypass that was used. So this is a part of the bypass. This is also a part of the bypass. All of this is a part of the bypass, including this. After it's done doing all of these injections, it closes RunDLL, it closes ConHost and CMD. And then you have the process tree. The process tree shows you the order of what happened. Sandbox DLL loader. As you can see here, these are the placeholders, because this then load the DLL file, which then load this DLL file, links to this, then this happens, so this C means that it closes this command, then everything gets closed in the end. And in the end, then you have the security health service. Well, I don't know why this is here. And then you have the mutants. I'm not sure that you guys know what mutants are. I don't think you guys actually know what mutants are. Have I ever talked about mutants of the file? It says mutexes, but this is mutants of the file. So this tells you that there's something wrong with the file. So if you see, oh idea, that's nice. So if you see that there are mutants of the file, well, so it has to synchronize with the device. The reason this has mutants is because the UI displays for him, but it doesn't display for me. That is unusual behavior. And then this gives you the... Okay, well, these are the session color mutants. The file UI has colors, it has a UI, but it doesn't really display for me. I will probably not explain this for now, because we have to move on to show that UI would only show in his device only, and not any device. No, the point is that he would see the GUI, but I wouldn't, because I was connected to AnyDesk. So he can see the application. For example, I can see this, but if you are connected to me with AnyDesk, you don't see this, although it's here. So you might be just trying to click this, click here, but you don't know anything because you don't see this. That's how they camouflaged. But you don't see, yes, exactly. That's how the camouflaged files work. And that's also how the manual mapping works. Keep ask QC, I have no idea what you said, but okay. Yeah, sure. I mean, this is not anything new, by the way. We have had those detected for thousands of years. That's why detections of those are mentioned in the scripture guide. So then we go to the other reports of the same thing, and here this is more better, because you have a different sandbox antivirus scanner. Then you have the indications, so this tells you exactly what's going on. So this shows you the P header, so the file contains section with special characters. This means that it uses Unicode characters, or special characters like Spanish characters and stuff like that. And then you see all of the same things that we just had. This also shows you that it is a virtualization invasion, because it doesn't show. And then this is a non-application layer protocol, because application layer protocol, because it shows on his device, but it doesn't show on my device. And then you have the processes extra info. And it also shows you what files it dropped. It dropped this file, which is... Obviously, this is because of the UI itself. So this is also why the security health was executed. Then you can see the screenshots, because this vendor tells you if the file is malicious. But when you execute the file, you only see readme DLL, so the same DLL file that we just uncovered in the previous ones were here. So This tells you that the file just tried loading readme.dll with run.dll, because you see the title of the icon, the window. And then you have the VirTotal Cape sandbox. It's not really that useful, but it still shows you there, for example, the command line, like run.dll, library, stuff like that. So it shows you the things that are not that useful, but sometimes, maybe sometimes, it will be nice. Then it shows you the volatility of the file, behavior, payloads, dropped files. It shows you pretty much nothing, because there's nothing to display, because this is a very bad antivirus. But sometimes it shows you screenshots. It also shows you some network connections. So it's a very good antivirus stuff in general. So we have established what to look for. We also established exactly how to tell if the file is suspicious. Do you guys have any questions related to this detection? Not detecting the file, yes, as I said. All you have to do is scan the file. So, yes, well, yeah, you have to upload a load virus photo to understand how it works. Basically, that's it for today's webinar. Um, so the detection of the file was not that easy, but it was not also that horrifying or hard. So I hope that you guys learn from the guide. Right. So I hope that you guys learn something from the guide as well. Otherwise, you'll not be able to really comprehend what I talked about. So what you guys have to learn the following things: spoken tools and text tools. You have to learn these two because they are highly inspired by Red Lotus. Both of those tools. They are better than Red Lotus because these guys know how to code. But they are also very highly inspired by Red Lotus because we released those types of scanners. Yes, text tool is very nice. It is very useful. After the file is bypassed, there's the file to the event is still modified and internal tracer does also bypass internal trace. If the file is deleted, it will leave a trace, internal trace, yes, but from the Lotus bouncer PowerShell commands don't work. Depends which ones, because you also have to enable bypass policy for them to work. We really stopped using PowerShell commands for a long time. Anyway, what do you mean advanced? Well, you don't really need all of the PowerShell commands. Well, I mean, yeah, that makes sense actually. Well, if you have any commands that don't work, you can mention them in the course chats and maybe we can rewrite them. We most likely will. Something similar to this, so that is, well, yeah, that's how journal trace works, really. Color trace. That's interesting, to say the least. Color trace. Okay. And that looks nice. That looks nice. Oh, that. It does work. Uh, what is that? That's not our. I don't think that's our command. Review events. So what this does is that it is supposed to. So yes, but it is supposed to. Yes, but it is supposed to leave the CSV file after it is done scanning. So it will return a lot of error messages, but in the end it will return the CSV file as well as results. We'll have to rewrite that. Yeah, it will show. It will print thousands of error messages. Yeah, and it's a very old tool. It's actually a very old tool. You are probably better off just using full event log view. Full event log view. So that also works. Anyway, with that being said, that is it. So see you guys next time. Maybe tomorrow. Maybe after a week. I don't know. You're welcome. If you guys have any questions, then make sure to post in host channels. Okay, goodbye.